before I start my today's class. That is one point. And second thing, now in this introduction to Oracle, I would say first a kind of question it is, what is Oracle? So I come with this point to a definition like Oracle is a product of Oracle Corporation, right? Introduced in the year 1977 as Oracle 1.0 version. That is one point. Okay. And second thing I would say, this is what is Oracle. These 3 points I highlighted. It is a product from Oracle Corporation introduced in 1977. But before to it, here something important you need to understand. I said it's a product. No? What type of product it is? RDBMS. Oracle is a RDBMS product. Okay. And now this word RDBMS is, I won't write another point. First, let's be clear on this now. RDBMS. Now, in this RDBMS, you need to first know what is database. That is first point. Then you need to know what is DBMS. And then you need to know what is RDBMS. Yeah, so indirectly, you have three terms that which will be described from this word called RDBMS. What are the things I said? First, we'll understand database. Then we'll understand what is database management system. And then we'll understand what is relational database management system. Then we'll come back and continue the introduction part of Oracle. And reason why I'm talking this, because this point or this word you need to be quite very clear. So let's understand that. Okay, first term, what I explained is what database. Okay, and remember here. Remember always in computers, whenever you want to organize data, there are two ways you can say. Two ways. What do you mean by organizing data? It's about storage. It's about modification. It's about deletion. It's about insertion. A lot of other activities. They all come under a category of what? Organizing the data. And in the two ways we have. One is old technique, it is called file system. Second is our topic, database. Yeah. File system is what? Simple. Creating a file and managing data. Creating a file and managing data. How do you create a file? Answer. Two ways. Two ways to create a file. Okay. What are they? One. It is called one is using built-in applications, and second also I would like to write using programming language. Yeah, two ways we have. Obviously, managing data through file definitely will not be a good way or the best way to organize data, but still I would say that is one way of organizing data. Now we are not putting our discussion onto what is best, what is worst, what is best, and what is what alternate techniques we have. Those things we are not talking. I'm just giving you an idea that this is, you can call, like, file system is kind of legacy. Okay, it's like old technology, old way of organizing data. Okay, and what are the two ways I said? One, built-in applications. Two, programming languages. Now remember, under built-in applications, what you can use, these all are examples. Notepad, WordPad, MS Word, MS Excel, etc. Yes. These all applications will support to create a file, and they will support you to manage data. And if you go to programming languages, obviously you're supposed to write program to do this. Example, C is one example. C++ is one example. Python is one example. Java is one example. C Sharp .NET is one example. VB.NET is one example. These all are what now? Programming languages. Where you are supposed to write a program, those programs will support to create a file, and those files will store data. Yes, that is what happens. But obviously, ready-made application, like if you use MS Word, Excel, they're easy to organize. But if you go with the same process in programming languages, compulsory, it's kind of experience, you can say, like, should be good in writing program, should be good in writing, creation of files, so that through those files you can manage your data. But you know something? No one prefers file system. No, I'm not saying like it doesn't have any importance, but still you have more disadvantages in organizing data through file system. Okay, what it is, for example, here, let me discuss few I'll list out so that we have an authentic point to answer that why are we not going with this legacy organization of data, that is by using file system. So for that reason, I'm highlighting this. What is it? I'm talking about disadvantages of file system. Yeah. And in this disadvantages of file system, first major drawback is no security. The moment I use this word, no security, people come up with n number of points to have a, to justify that we have security. In I do agree. I do agree. Notepad you may not have. A WordPad you may not have. MS Word may provide security, like you, because MS Word file or document you can call Excel file. These things can be protected with password. MS Word document can be protected with password. Excel file can be protected with password. But point is, whenever we create MS Word document or MS Excel file, and when you organize data in it, when I protect that file with password, obviously, data is protected. Assume like this. Assume I I I created one MS Word document. I created one MS Word document, and I protected with password, right? And that document I'll share with you. I'll share with you, right? So what will you do? You download that file, and whenever you open a file, it will ask you to authenticate with password. Since you're not the authorized user, since you're not, authenticated user, so obviously you cannot enter into the file. So it means data is secured from you, no? You cannot enter into a document. It means the content is secured. But point is, you cannot enter into the document. Okay, I understand. But what about that? What can you delete that file? Obviously, if you delete the file, then what is the point in protecting that file with password? Because however you lose your file, you lose your data. Yeah, even in that way, I would say that there is no security. That is the reason I'm trying to come up with the biggest disadvantage of file system is that there is no security. And one more point also I would highlight. One more point. One more point. What it is? Redundancy. Yeah, redundancy. Duplicates cannot be avoided. Yes, duplicates cannot be avoided. Redundancy cannot be avoided. Yes. There is another disadvantage of what? File system. If the same piece of data again and again you store into a file system, 100% every file, wherever you create, it will allow you to store that content. What is the problem in it? Two disadvantages. Unnecessary, same piece of data again and again you're storing is a wastage of memory. Yeah, and again it may create a sort of confusion. There is another problem. That is second disadvantage. Third, also, I'll say this is also important. Lot of topics are there in Oracle connecting with this. What is it? It's called always you find file system has data inconsistency. What do you mean by that? See, I'll give you example so that you can understand the word data inconsistency, right? It is a data inconsistency. What do you mean by data inconsistency? See, and before I continue, you have any questions to ask me on this introductory part of database, you can unmute yourself and can put forward your query. And second, this is because this is what I personally feel. This is not first time I'm teaching Oracle. I almost completed 140 plus batches on Oracle from past 20 years of experience. I carry on training. So keeping those things in view, any question that you have that you want to ask me, even at the end of the session, I'll give you some time so that you can unmute yourself, you can talk to me and can make your clarifications on the subject or on the content which I have covered today, so that things can be clear at your end as well as so that the next class can smoothly you can understand towards this database, because that is a minimum decorum, when you join as in a virtual class, attend the session for full. However, you are at your home, so keeping that point of decorum to a online session, uh, you just attend the session. If you have any questions, you can unmute yourself and you can ask me. If not, there is a chat panel available in the application. You can use the chat panel and can even ask your queries. Yeah. So now, so I was talking about data inconsistency. I'll give you an example to understand this, right? A small example. What I would do, for example, I'll create two files. Two files. One file I call stock.txt, and one more file I'll create called sales.txt. Two files I'll create. Stock.txt, sales.txt. In stock.txt, I'll have product number, product name, stock of the product. Okay. And this is like this 101 pens. Stock is 1800. 102 books, say 2500. Example of it. Now, this is the stock I have in my business, which is stored in a file called stock.txt. And then I have this information: product number, product name, sales, date, amount. Yeah. Here I store here 102 books, 18 date, today's date 29 September 25. Amount, say for example 2000. Yeah. Now my question is, whenever you store information in sales.txt about the product what you have sold, that books you sold 18 books in today's date. So my question is, the moment you write sales information here, do you really feel that this 2500 will be automatically reduces because that you have made a sales in the business? Do you really feel that automatically that particular value will be reduced automatically? Will it becomes like some 2480 something? Some example, rough example. Do you really feel so? Okay, I'll just make this for easy calculation. 20. Yeah. So do you really feel that the moment you make a sale, automatically your stock information will be updated to 2480? Definitely that will not happen. 100% that will not happen. No, never. That is what do you call data inconsistency. Though you make sale of 20 books, but this will still remain as 2500 only. If you want to make it 2480, you have to open stock.txt and you have to change that value from 2500 to 2480 manually. Yeah. So what do you call data inconsistency? Changes made in one table. Will it automatically reflect that value into another file? So answer is never. That is called data inconsistency. Yeah. Like that, we have many disadvantages. Yes. Now our topic, database. First point. How do you define a database? So you can call it is defined as logical container. Yes. Database is defined as logical container. Huh. What? Which contains what? Related objects. Here I use a word. What is the word I use? Logical container. With this, I would like to highlight even that database always provides two types of data. Remember that, please. At least remember. Coming classes will justify that. But remember, database always provides two types of data. One is called logical data and one is called physical data. Yeah. Physical data means the data which will be in hard disk. Logical data means that which will not have, that which will not in hard disk. The one in hard disk is physical. The one which is not in hard disk is logical. So what type of database is now? Logical container. Definitely in my coming classes, we will justify this with architecture. A small picture kind of thing I'll draw so that you can understand how database physically maintains data and how database logically maintains data. Okay. Yeah, this is the definition of database. And one more interesting, what did I use a word here? Objects includes what? List is there. List what? Tables, constraints, synonyms, sequences, indexes, clusters, stored procedures, stored functions, stored packages, stored triggers, stored types, etc. This is what the topic of Oracle is now. Whatever we are going to learn in Oracle are these topics. Tables are of types, constraints are of type, synonyms are of type, sequences are of type. That is what we are going to study in Oracle. Database is all about this story only. And one more point, one more. To understand about database, first we'll describe types of databases. First we'll discuss this. Types of databases. And remember, we have two types of databases. One type of database is called OLTP, and second type of database is called OLAP. What is OLTP? Online transaction processing. And second is online analytical processing. Yeah. And obviously, OLAP, when I use the word, it's obviously describing data warehouse. So obviously, what is our subject then? OLTP. What is that we are going to learn? OLTP. Online transaction processing. Now, keeping this database in view, let's describe what is DBMS. Don't forget, we are going with this word description. Okay, don't forget that, please. Here, I use one word, na, RDBMS. Connecting to that, I'm making all these things. Because first we understood what is database. Now I'm trying to come up what is DBMS. that is described as database management systems. Yeah. And now you say me, what is DBMS? How do you define DBMS? Simple. Collection of software programs. Yeah. Used to store, manage, and retrieve data. Yes, three things. First point, what did I say? Software programs. It means we are provided by some ready-made programs, and they are such programs, they will help us to store, they'll help us to manage, and they'll help us to retrieve data. And especially remember, this retrieval is, it is based on three factors in database. Three factors. Yeah. What do you call this? This is A, this is T, and this is R. What is A? A is about accuracy. T is about timeliness. R is what you call relevancy. Accuracy, error free from errors. Yeah. Timeliness, within the time. Relevancy, related data is how you describe ATR. That is DBMS. And now remember, we have been provided to work with types of DBMS. What are they? One is called HDBMS, second is called NDBMS, and third is called RDBMS, our third topic. And fourth is ORDBMS. Yeah, description. H is hierarchical. DBMS, same. N is network. R is relational. OR is object relational. DBMS. And in these three, these two are outdated. We don't find them now. Yeah, this is outdated. This is also outdated. This is ongoing with development. RDBMS and ORDBMS are ongoing with what? Developments. Yeah. Yes, please. You have anything to ask me on this part? You're comfortable what all I said till now? Everyone have asked. You have any still questions to ask me on this?
No, clear.
You're clear? You understood what exactly you are trying to come up with? Okay, fine. Okay. Samal, can you hear me? Yasir? Pradhan? Ramesh? What about you? Rahul? Okay.
I have one question.
Yes,
Uh,
please. Go ahead.
uh, Nowadays, actually, NoSQL, that is the non-relational database that are
Mm,
using. So, what is the advantage of using that NoSQL? Means
okay.
already relational database is there.
Mm, mm, okay.
So, why we will go for that NoSQL?
Okay, just let me first complete this part of what I'm trying to come up with RDBMS. Then it will be easy for you to understand when I explain you with comparison, how this NoSQL will support. Okay, so
Okay.
once we'll understand, not in depth, like everything we cannot understand in introduction classes. First,
Yeah,
we'll
for
try
just
to
introduction. Yes,
just for
fine.
basic of RDBMS. Let me first explain you. After that, I'll compare and explain you how it is going to work for us. Okay.
Yeah. Okay.
All right. Now, going forward on this, here I come up with RDBMS that you can describe as relational database management systems. That's what you call RDBMS. Yes. And how you actually write RDBMS? Like this, R plus DBM. DBMS already I said on the top. On the top, I said, we got some programs. Those programs will help you to store, manage, and retrieve data. Yeah, that is what DBMS. Then what is R? Remember, R technically it stands for referential. And what it is? It is one of the integrity constraints. So you let me make you clear on it. We have one topic to study in my coming classes with practical that is called constraints, integrity constraints. So there we'll understand what is called domain integrity constraint, what is called entity integrity constraint, and what is called referential integrity constraint. Constraint topic, maybe we will understand that. But one simple, I would say, referential is about something related with creating relationships. Creating relationships. And what relationships here I describe? Three. One-to-one relationship is one category. Then one-to-many is one more. And third one is many-to-many. Three will be there. And in this three, this one we have for direct implementation. And this one also we have for direct implementation. And this one we have is indirect, or you can say, or actually we don't have a support of it. If you want to do it's a lengthy process when you got indirect support. Otherwise, one-to-one, one-to-many, we got very perfect support with lot of scenarios, examples, we can justify them. Otherwise, you generally get it's just only a discussion, about what you call one-to-one and one-to-many. Many-to-many, we don't have. Even if you have, it's a lengthy and indirect process. That is what the description of R. Okay, and one more thing also I would say towards RDBMS. What it is, RDBMS was introduced in the year 1970 by Dr. E.F. Codd. E.F. Codd, and has outlined 12 rules, often called Codd's rules. These rules I'll talk with practical justification at the end of the subject. Yeah, because to understand those Codd's rules, you should have knowledge of SQL also, should have knowledge of PL/SQL also. Total knowledge of Oracle, if you have, then only you can work with the Codd's rules. Then only you can understand Codd's rules. Yeah. And one more point we have, one more point. What it is, especially connecting with these 12 rules, not necessary that your software should satisfy all 12 rules. No, not necessary. Mhm. Okay. Now, what I was saying, from these 12 rules, Dr. E.F. Codd has mentioned one limit. Dr. E.F. Codd has mentioned one limit. What it is? Right. The limit is like this. Among 12 Codd's rules, any database software satisfies 8 or 8.5 rules, then it can be considered as pure RDBMS. Yeah. How many, what is the limit they give? Among 12 rules, any database software, it satisfies 8 or 8.5 rules. Bas, enough. That particular software can be considered as RDBMS. The third rule I'll discuss. Third rule. Third rule. And what is the third rule we have? For example, yeah. Third rule, what we have? RDBMS always presents data in two-dimensional format. Two-dimensional format. That is what you call rows and columns. What do you call this? Table format. Yes. Table format. Rows and columns. Yes. And going forward on this, if you see the second part, here, these terms are there, no? This row, column, this differs actually. If you describe column, in one database, they are called fields. In one database, they are called identifiers. In one database, they are called attributes. Yeah. And in this row has a term again. Row in some database, they call records. In some database, they call tuples. And when I use the word table, table can be described by these terms. In some databases, they call as entity. In some databases, they are called, table is also called entity. Table is also called as, object. And in some databases, they are called, relation. Yes. Table is called by 3 names, row is called by 2 names, column is called by 3 names. So it differs from one database to other database, the terminologies that which we use. Yeah. Now you see, just to saying a word RDBMS will not be sufficient. No? So just saying that Oracle is RDBMS product. So obviously they'll ask you like, what is RDBMS? Then to explain what is RDBMS, your story should begin in this way. And when you say that RDBMS is expanded as RPlus, definitely they'll ask you, what do you mean by DBMS? And once you say it is database management, then they'll put you a question on what is database. Then we go in this way. A comparative point, I'm saying. Yeah, if you already have some basic knowledge on fundamentals of database, that is different issue. But this is for a person like who is new to environment of database. For them to have a quick review kind of thing, I have come up all these fundamental points. Yeah. And finally, I would say one more point here. RDBMS always represents data in something called normalized way. Yeah. So that is presentation, means data looks like rows and columns. Here, normalized way. Here I'm talking about presentation, how you present data. Yes. What are the normal? What do you mean by normalization? Normalized way. Then a table can be normalized in different ways, often called normal forms. Yeah. What are they? We got all these. 1NF, 2NF, 3NF, BCNF, 4NF, 5NF. Yes. Every normal form has some set of rules. And one more point also, I would say, we are going to discuss them. But as far as my experience is concerned, even to a real time, this is what I noticed. Only first 3 normal forms we mostly come across. Mostly. Yeah. The other four, the other three, very rare we come across. So that is the reason, even as a developer of SQL or Oracle, compulsory you should have very clear picture with rules, with examples, with understanding scenarios, how 1NF, 2NF, 3NF is going to work for us. Yeah. Clear now? And one more point. One more point. So I won't discuss them now. What is normal form? What are the rules of the normal? Those all things come in class. And one point I would say, to understand this normalization and denormalization, the prerequisite compulsory you should have knowledge on constraints. This part here. Yes. Only when you are clear with the constraints, then only you'll be in a position to understand normalization. If you are not aware of constraints, then normalization, even 1 month, if I explain nothing, you understand of it. Yeah. That is RDBMS. That is how the term RDBMS we have described. Organizing data, database, then what is DBMS, then what is RDBMS. Yeah. Now, let's continue describing few more points connecting with this, introduction to Oracle. Okay, and I already said you, right? 1977. I said like 1977, for the very first time, Oracle was introduced as RDBMS product with a version 1.0. And now I would say, when in 1977, when they introduced Oracle for the very first time, it was not found to be the best product for database. People, whoever used it, they found, like, syntaxes were not accurate, compilation techniques were not correct, even data management was not perfect. They found n number of disadvantages with it. N number of disadvantages they found with the software. Then they found that the database software, but that it's not that easy to use. Like, they found many disadvantages in it. So what Oracle Corporation has done, they hold that product of Oracle 1.0. They immediately started making changes in the software. And then what they did in 1979, yeah, here I say, in 1979, before I go, you asked me that doubt, right? Okay. First I'll compare, then you'll understand how this, later I'll talk on this other point. Yeah. What I would say, as you asked me, I said, like, if you have knowledge of RDBMS, at least whatever I covered here, these points, at least these points, then it will be easy for you. So here what you learn is, especially when you talk about RDBMS, and you asked me with another one, I thought NoSQL. So what you learn here, in relational database, you always find that you are provided with fixed structure for data maintenance. Fixed structure. What is it? What do you mean by fixed structure? That is what the point is. Rows and columns. That's it. Any way, any RDBMS software you take, its purpose is to provide data in the form of what? Rows and columns, table format. And in NoSQL, which is actually called non-relational database, where you find data can be presented in different ways. Different ways. Like what? You can present data in the form of key value pair. You can present data in the form of columns. You can present data in the form of graphs. You can present data in the form of JSON. Yeah, these are different ways. It's not like fixed way. And when it comes to even, transaction, that what you do, transactions, that what you do in database, whatever you do, always they follow acid properties, ACID, transactions related. Whereas in NoSQL, yeah, we follow base, base. You understand? Base, properties. In NoSQL, that is called non-relational database, we use base properties, and here we use acid properties. Right here, what is acid properties? As atomicity, consistency, isolation, durability. And base is basically available soft state, something called eventual consistency. That is base properties. So you got different approach you have in this. Different approach. Okay. Like that, you have different cases you find that will be related to, understand the, comparative differences that you find between RDBMS and NoSQL database. And one more point, if you just talk about this RDBMS, these are all examples: Oracle, MySQL, SQL Server, PostgreSQL. They are all examples on this. When you talk about NoSQL, MongoDB is one example in it. MongoDB. Cassandra is another example. Couchbase is another example. Right? And some more are there, like some exclusive databases are there. They come under category of what? NoSQL database. Hmm. And what type of application that you develop? If it is RDBMS, banking applications are developed, ERP related applications, CRM related, applications that are developed on on relational database. But when it comes to NoSQL, you can find big data, IoT, social networks, real-time applications, analytics. All this information can be recorded by using NoSQL. Hmm. Comfortable? Do you understand what the doubts what you asked me? Only just a few introductory points I covered. Otherwise, we have a lot of other differences even that you find between, RDBMS and NoSQL. Okay, go then. Is this clear? Was it a doubt by Gangadhar or Ramesh?
Yeah, clear.
Sure. Okay. Now, going forward on this, here we learn in 1979, Oracle 2.0 was released, and it became and it has become the first commercial relational database, or you can call first SQL database. That is how description is provided about Oracle 2.0. Right? And third one that you learn is Oracle is used as backend. Yes. Oracle is always used as what? Backend. Hmm. And another interesting thing, initial versions of Oracle were RDBMS. And there is one specific version. I'll write the number. I won't discuss that now. Just I'll write a number. There is a version called Oracle 8i. From Oracle 8i. And later versions, they are ORDBMS. That is called object relational database management systems. From which version it is? 8i. So obviously, whatever version we are going to use, 8i, 9i, 10G, 11G, 12C, 18C, 19C, 21C, they all come under category of what? ORDBMS. Yeah. So that versions and all next topic I'll cover. But just giving you some idea on it. Okay. And now, one more important point here. Oracle is client server technology. Yes. And listen carefully, especially this point. For practice purpose, for practice purpose, we make Oracle install on Windows operating system. We install on Windows operating system. Whereas if you talk about Oracle in real time, wherever database is being used as backend in IT companies, they 100% install Oracle software in Linux operating system. Yes, because Linux makes, double security for your database. Linux. Yeah. Working will not change. Syntaxes will be same. Commands will be same. Right? Only the difference that you find is environment will differ. If it is Oracle, if you are using it on Linux, right? Only operating system. Even you are using in Windows, if you are using in Linux, only OS will change. The way you enter into software, that may change, but rest of all will be same. Commands will not change, syntaxes will not change, working will not change. And the basic functionality will not change. You know, everything will be same. Everything. Only OS will make a difference. Hmm. Right? And one more point, I'll write. One more point. What it is. Initially, Oracle was CUI. Oh, character user interface. Initial. But then, when it was CUI, for some time people liked it. For some time, syntaxes and all. But after Microsoft introduced with the SQL server, then people started comparison. People started finding more advantages than of Oracle with respect to working. I'm saying working environment is far better than, with respect to your, yeah. So what does say? So working wise and everything was fine with CUI, character user interface. But as I said, like once after introducing the SQL server, people started comparison. People started feeling like SQL server is giving you, flexible environment. It's giving you a kind of wizard based interaction to the database. Then Oracle Corporation felt till that time, what people used to do, whoever used to work with Oracle, they used to work on third-party tools. They used to download one third-party tool. They used to install the tool. They used to configure Oracle in it, and then they used to work on it. But then what Oracle Corporation has done? From this version, I would say, from this version, from Oracle 11G and later versions, it has been introduced with GUI, graphical user interface. Yes. And this GUI tool they developed in Java. They developed in Java language. And from then you find like even Oracle software, whenever you install, now we are being provided even with what? That ready-made tool, GUI tool. Because of it, now communication to Oracle has become little easy for us. Yeah. And finally, the last point I would highlight, as I said, always write Oracle word in capital letters. Yes. Oracle is provided with something called database engine. Yes. And in this word Oracle, E is there, E that stands for engine. What type of engine? L, logical engine. Will it do only logical operations? No, it would even do arithmetic calculations, or you can call analytical computing. Computing. And O is oak. R is ridge. Okay, that is how it stands for. Oak ridge, arithmetic calculations, or analytical computing, logical engine. That is how Oracle stands for. That is the reason I said whenever you write a word Oracle, always write in capital letters because it is an abbreviated term. That's it. From my end, I'm done. You have any questions to ask?